Hi, today I'm going to be talking about virtualization, hypervisor, the difference between horizontal scaling and vertical scaling, and about the business process as a service, and the three key characteristics of service orientation in cloud computing. I'm Sharina Glinadera, ID number K2406664, and this is for Cloud and Beyond Week 3. Now, let's get started. What is virtualization? Well, virtualization is the process of creating a virtual meaning software-based version of something that would normally be physical, like a service, storage device, network, or even an entire operating system. Instead of running one operating system directly on one physical machine, virtualization uses a layer of software to split that physical machine into multiple independent virtual machines, each acting like its own separate computer with its own OS and applications. This means a single physical server can run several different operating systems at once, sharing the same underlying hardware resources, CPU, memory, storage, while staying isolated from each other. Neat, isn't it? It's the foundation that makes cloud computing possible because it lets providers use hardware much more efficiently instead of dedicating one whole machine to one task, which is really good and convenient. And then moving on to hypervisor. Now, what is hypervisor? I'm going to explain that. So, a hypervisor is software that actually makes virtualization happen. It sits between the physical hardware and the virtual machines, and its job is to create, run, and manage those virtual machines, allocating CPU, memory, and storage to each one, and making sure they don't interfere with each other. There are two types: Type 1, the bare metal hypervisor, and Type 2, the hosted hypervisor. Type 1 is installed directly on physical hardware with no underlying OS in between. Examples could, um, One of the examples could be Microsoft Hyper-V. These are faster and used mostly in data centers and enterprise environments because they talk directly to the hardware. And then type 2, the hosted hypervisor, it's installed on top of an existing operating system like an app, like Oracle VirtualBox. These are easier to set up and are more common for personal use, testing, or development, but they're slightly slower since they have to go through host OS first. And then move on to the difference between horizontal scaling and vertical scaling. Both are ways to handle increased load or demand on a system, but they do it differently. So, for horizontal scaling, it's scaling out. So, instead of making one machine bigger, you add more machines to share the load, like adding extra servers to a cluster. This is more complex to set up because you need load balancing, which will be discussed in a later video, load balancing, and coordination between machines. But it scales much further and is more fault tolerant since it's one machine. If one machine fails, the other one keeps running. And then vertical scaling or scaling up, you increase the power of a single machine. So, by adding RAM or a faster CPU or more storage to the same server, it's simpler to implement since you're not changing the architecture. But there's a hard limit. Eventually, the hardware can't be upgraded any further, and it usually means downtime while you upgrade. In short, vertical scaling make the one machine stronger, and then horizontal scaling add more machines to share the work. Cloud platforms usually favor horizontal scaling because it's more flexible and more resilient. And we're going to be moving on to the fourth question, which is what is business process as a service, or and then explaining it, BPaaS. So, business process as a service is a cloud service model where an entire business process, not just software and infrastructure, is delivered as a service over the cloud. It sits at the top of the cloud service stack above IaaS, PaaS, and SaaS. Instead of a company building and managing a whole process internally, say payroll, HR management, customer support, or supply chain management, they outsource that entire process to a provider who delivers it as a ready to use cloud based service, usually as a subscription or pay per use basis. The provider handles the people, processes, and technology behind it. For example, a company might use it provider for its entire payroll process. The provider handles calculations, compliance, and payments, and the business just plugs into the service rather than running its own payroll department and software. This lets businesses focus on their core operations while cutting costs and complexity around processes that aren't central to what they do. So, moving on to the three characteristics of service orientation in cloud computing. So, service orientation is the principle that cloud resources are delivered and consumed as discrete, well defined services. The three characteristics are usually described as loose coupling, abstraction, and reusability. Now, let's talk about loose coupling. Services are designed to be independent of each other. A change in one service shouldn't break another because they interact through standardized interfaces rather than being tightly wired together. This makes systems more flexible and easier to update or replace piece by piece. And then, second, is the abstraction. The internal details of how a service works are hidden from the user. You only need to know what the service does and how to interact with it, its interface, not how it's implemented behind the scenes. This simplifies usage and lets providers change the underlying implementation without affecting the customers or consumers. And then the third is reusability. Services are built to be reused across different applications and contexts rather than built for a single one-off purpose. A single well-designed service like an authentication service can be used by many different applications by saving development time and promoting consistency, which is really useful. And then together, these characteristics are what let cloud services be mixed, matched, and scaled flexibly instead of being locked into rigid monolithic systems. To conclude this report, in summary, virtualization and cloud computing work hand in hand to make modern IT infrastructure more flexible, efficient, and cost effective. Virtualization, enabled by hypervisors, allow physical hardware to be shared across multiple virtual machines, laying the technical foundation for cloud services. Building on this, organizations can scale their systems either vertically or horizontally depending on their needs. Horizontal with horizontal scaling, generally offering better resilience and flexibility for cloud-based systems. At a higher level, service models like BPaaS show how cloud computing has expanded beyond just infrastructure and software to encompass entire business processes, allowing companies to outsource complexity and focus on their core strengths. Underlying all of this is principle of service orientation, loose coupling, abstraction, and reusability, which ensures that cloud services remain adaptable, easy to maintain, and reusable across different systems. Together, these concepts illustrate why cloud computing has become the backbone of modern digital infrastructure, offering businesses like agility, scalability, and efficiency needed to stay competitive. And that concludes my video presentation today. I hope you've learned something. And yeah, it's better to watch the past video recordings in the future, as I will be discussing again similar topics because of cloud computing, and this is Cloud and Beyond. Thank you so much for watching. See you in the next one. Bye.